Hi guys, so welcome to part two of interpreting different data sets. And so I want to work on now, if it asks you to interpret each measure of variation. And so, if you, like many of you probably know, my mom teaches sixth grade math as well. And so, what I did is I had her give me her data. She teaches two different separate classes of 20 students each. And so, I had her give me the data of a quiz assessment for class 1, and then there is her second class, class 2. And I had her give me the data. These are the quiz scores. It was a quiz out of 10 points of 20 students from each class. So for class 1, my first thought is I want to make a dot plot because I'm going to be talking about measures of variation. So when you have something like the measures of variation, I'm not really interested on what was the average, what was the mode, but I'm really kind of wanting to use this data to maybe answer a question of which class did better. I want to know which class did better. And what I'm going to do is I'm going to use the data from each class, and I'm going to use my different measures of variation to help me answer and talk about, interpret which class did better. So class 1, I'm going to draw a dot plot, and this will break up my different classes. In class 2, I'm going to draw a dot plot. Now there's 20 different data values, so we are going to have to write a little bit tiny, so try to write small if you can. But I know that my quiz scores were out of 10, so this is all the people that scored 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same thing over here. This class 2, I want to visually show how many kids scored either 0 through 10. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So my data value possible sets are 1 through 10. So class 1, their lowest scores were, they had, 1, 2, 3, 4, 5, 6 people score 6 points. 1, 2, 3, 4, 5, 6. So 6 people each scored 6 out of 10 points. My next up from that is 7 points. So I had 3 students in class 1, or she had 3 students in class 1 score 7 points. 7 points out of 10. 8. Ooh, wow. 1, 2, 3, 4, 5, 6, 7. 7 students scored 8 points. 1, 2, 3, 4, 5, 6, 7. 9 points, 4. 1, 2, 3, 4. And that was it. No one actually got a 10 out of 10. So the highest scores were 9 out of 10 points, and the lowest scores were 6 out of 10 points. So as a teacher, you really do want consistency. This would be very good to know that no students got below a 6 out of 10%. So that's pretty good. Well, let's look at how class 2 did. So class 2, if I'm looking over here, oh boy, who knows what happened here, but someone, I guess, got a 0. I'll have to talk to her about that. It happens. Let's see, 2 people got, ooh, that's not good. 2 people got 3 out of 10. 4 people got 4 out of 10. 1, 2, 3, 4. Oh, wow. And then we have a big gap. So then people either seem to get an F, or on this side, one person got an 8, but the rest got A's. So then 5 people got 9 out of 10s. 1, 2, 3, 4, 5. And it looks like 1, 2, 3, 4, 5, 6, 7 people got 10s. 10 out of 10s. Wow. 5, 6, 7. So just by looking, what would you say right now? Which class did better? As a class, what would you say? And I wish I could hear your guys' responses because you always say such brilliant stuff. But right now I'm noticing, okay, yes, this class right here, a lot of people got really high scores. but it seems that people either got an A or an F. Whereas this class, the scores weren't as high, but they were very consistent. So what I want to do is I want to use my mean, my different quartiles, and my mean absolute deviation to help me explain this data in technical terms. So let's go ahead and first find the mean. Now, to save you time, what you would do to find your mean, if you want to do it on your own, you can. You would add up, each one of these would be representative of 6. So 6 plus 6 plus 6 plus 6 plus 6 plus 6. Or what you could do is say 6 points. If 6 people got 6 points, that's a total of 36 points. If 3 people, 1, 2, 3, got 7 points, well, that's 21. 8 times 1, 2, 3, 4, 5, 6, 7, and so on and so on. So you could add up all the different values, and you would end up getting, 149 if you added up all of these different dots together. And then same thing over here. This would be worth 0, plus 3, plus 3, plus 4, plus 4, plus 4, plus 4, plus 8, plus 9, plus 9, plus 9, and so on, and you would actually get 149 as well. Now each of these is out of 20 students, out of 20 values, so I would divide each by 20, and so kind of like we've seen before, this has the same mean. So my mean for each is going to be 7.45. 7.45. So even right now, if I were to see something that asked me to, interpret your data, interpret your mean, I could say something like, well, both class 1 and class 2 have an average score of about 7.45 points. So that's about a C. So I could say each class is averaging about a C. So, I mean, does that really help us talk about these different values? Not really, because here's two different things. This mean, I mean, it tells me that most students are around this ballpark, but over here, are most students at a 4.5? No student even had that, because so many of them are to the right and so many of them are to the left. So let's talk about what our median and really our interquartile range and our MAD is going to represent. So let's go ahead and for this data set, what we're going to do is find our median, quartiles, and our MAD. So unfortunately what we need to do is we're going to make a different dot plot now. Or I'm sorry, not a dot plot, but we're going to order these from least to greatest. And so try to write kind of tiny because there are a lot of different values. There's 20 of them. So I'm going to say there's 6. So there's 6 sixes. So 1, 2, 3, 4, 5, 6. There's 3 sevens. 1, 2, 3. There's, 1, 2, 3, 4, 5, 6, 7. There's 7 eights. 8, 8, 8, 8. 1, 2, 3, 4, 5, 6, 7. And there's 4 nines. 1, 2, 3, 4. So if you ran out of room, that's okay. It's really just to help us find our different everythings. And so here, let's go ahead and find, where's my median? Where's that middle point? What could I say my median is? Well, if I go, I know that there's 20 values, so if I go 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I know that then right here is my middle. So right here is my middle, and 8 and 8, that gives me an average of 8, so my median is 8. So this tells me that my middle score is 8. Everything to the left is going to be smaller than 8, and then the upper half of my data is greater than 8. Well, let's find our first quartile, our quartile 1 and our quartile 2. 3. So I know that my lower half, this is the lower half of data, has a median of, if I go here in the middle, it's going to be a median of 6. So it goes right here. So here's my quartile 1 with a median of 6. And then if I look, well, what is my upper half middle? I can find the median of my upper half, which looks like it's going to be 8. So Q3 is 8. So then to find my interquartile range, I would do 8 minus 6, which would equal 2. So my IQR is 2. I know my median is 8. the last thing I need to do is find my MAD. So already I'm thinking, well, that's pretty close. If each of my range of my middle half of data is only 2 away from each other. So that's pretty good. So let's go ahead and see if, oh, my screen turned off. I hope it's still recording. Okay, so let's go ahead and see if we can find our MAD now. MAD. So what I need to do here is I want to add up for my MAD. I need to add up all distances away from my mean. So I look here, I have a bunch of 6 values. So I have 6 values, and it happens to be a value of 6, and I want to think that's how far away from my mean. Well, my mean is 7.45. My mean is 7.45. So I think first, so 7.45 minus 6, and again, you can use this on a calculator. 7.45 minus 6 equals 1.45. So each of these values is 1.45 away from my mean. To save me time, instead of adding 1.45 plus 1.45 plus 1 6 times, I can just say, okay, 1.45 times 6 plus, and now I look here, so 7. 7 is going to be 0.45 away from 7.45, and there's 1, 2, 3 of them, so that's times 3, plus 8, I can again, if I needed to, 8 minus 7.45, which gives me 0.55, times 1, 2, 3, 4, 5, 6, 7, there's 7 of them, plus I have one more value as 9, so 9 minus 7.45 equals 1.55. And there's 1, 2, 3, 4 of them, so times 4. Now, to save us some time on this video, what you would do and what you should do, I'm going kind of fast because this should be a review. I'm going to add all these up together. If you want, you can go ahead and do so now. And basically what you should get, if you add up all your differences from the mean, you should get 21.9. And then I find the mean, remember, of my differences. That's how I find my MAD. And so I do 21.9 divided by, that was 20 values. So this gives me an MAD, a mean absolute deviation of 1.095. So I just figured out my MAD. My MAD equals 1.095. And this means the average distance from my mean of all of my different values is going to be about 1.095. So that's pretty good. That's telling me that they're all pretty close together. So let's kind of contrast that now with the class 2, So I'm going to go kind of quickly. If you want to go ahead and try to find all this on your own, I'd pause this video and do that now. If not, I'm going to go very quickly through all of this. It's kind of like you try it on your own and check. So here, if I were to line up all of my different values, I'm going to, I have 0, 3, 3, 4, 4, 4, 4, 8, 9, 9, 9, 9, 9. And then there's 7 tens. So 1, 2, 3, 4, 5, 6, 7. Okay, so my median. My median here, it looks like it's going to be 9. So here's my middle. My median is 9. So already this does have a higher middle value. Okay. But how close are my values away from that? Well, my third and first quartiles, this one is going to be, if I count all the way, it's going to be 4. So Q1 is 4. So already I'm thinking, well, see how here my lower half is a lot lower than 6. So 4 is a lot lower than 6. So my middle half is going to be very drastic, a difference. But if I go over here, oh man, well, my third quartile is actually right here. And that's 10. So that's a big difference between 8 and 10. So that's already giving me a lot of insight. And if I were to, oops, I'm sorry. This is not 8, this is 10. So my IQR, the difference between the middle half of my data will be 10 minus 4, and that's a difference of 6. So my IQR is 6. That means that these can vary no more than by 6. That's really, if I were to interpret my IQR, it's telling me these values can't vary any more than 6. Well, these values can't vary any more than 2. So I know that these values have to be a lot closer to 8. These values, even though it's a median of 9, they're going to be very far away. So then the last thing I want to do is we're going to find our MAD of the data. So what you would do is you would add up all your distances away from the mean, and then you divide it. Then, like we did before, divide by number of values. So go ahead and see if you can add up, again, we have a mean of 7.45, so see if you can add up all of these different values, and even using this, how far away are they from 7.45, and see if you get the right answer. So if you did that, if you added up all your distances, you should get 56.3. I'm going to divide that by 20, and that gets me 2.815. So this MAD, this mean absolute deviation is 2.815. Now let's talk about, okay, which class did better? And we're going to use our data. That's how we are interpreting, is we're explaining, putting into words what we have found. So I'm going to get a separate piece of paper. So I want you to keep this out, because we are going to be referencing this in our interpretations. So, interpretations. This is our last one. I know this has been a lot. You guys are awesome. All right, so our interpretations. This might be talking about, okay, if someone were to ask you, well, which class did better, what would you say? So, something that you can say, they both had the same average. So you could say both classes have same average quiz score, but, well, if I'm looking at the data from class 1, I could say, but class 1 was way more consistent. And you could say, for example, it had a lower, let's see, well, it has a lower IQR by, it looks like 4 points, and a lower MAD by about, it looks like 1 point. So that's telling me right now, okay, so even though they have the same average, class 1 had a lot closer scores together, where, yeah, in class 2, a lot of people did better, but also a lot of people did worse. So you could say something like class 2 scores were more spread out. You could say, I mean, there's really a lot that you could say. You can say period 4 had a larger mode. So class 2 scores, they were more spread out, but they did have a higher mode, which was of 10. So a lot of people scored 10 out of 10. So this is what it means. This is all it means by interpreting your data. So there's a lot more. For the sake of time, we'll kind of stop here, but there's a lot that you could say. Just by looking at this, I could say the lower half, like class 2 had a much higher middle half, but a lot lower of a lower half than period 1 or class 1. You could talk about, okay, the ranges. So my inner ranges, this one's a lot greater of an inner range, smaller of an inner range. You could even find the range of, here's 10 to 0. So here my range is 10. Here my range is 3. So that's actually a crazy assumption right there, as you can say the ranges. That really gives me no meaning to what this stuff means, because all the values range for about 10, where this only ranges for about 3 points. So even if my lowest was 6, I know that it can't be any lower than 3. And it can't be any higher than 9. But again, it's all just about how you talk and deal with this data. So that's it for now. You guys have some homework. I hope this cleared up sort of in some interpretations. Let me know your questions so I can help you. You kind of have an overview of what the rest of the week will look like. So good luck with it all. Miss you guys. Please let me know what you need or any questions.